We move on to reciprocal theorems, and reciprocal theorems I think are absolutely fascinating, and they also are, to me at least, a bit of a paradox, because at first glance they may seem completely obvious. You may remember Betty's law from your structural analysis class. But the more you dig, the more curious these things become. In fact, they're so rich that I think that it's merited of like PhD sort of scholarship. These reciprocal theorems have to be restricted to structures where the displacement is directly proportional to the load. So the kind of structures we're doing in ARCHE 501. All right, so I have this potato. It's stable, and there's a point A and a point B, and there's a force A, let's call it PA, and a load at B, let's call it PB. And deltas are going to be the displacements. Now, I'm going to try to leave the camera just like this here. So, delta AA is the displacement component of point A parallel to PA due to PA. And delta AB, and this is a little tricky here, is the displacement component at A parallel to A but induced by B. And then delta BA is the displacement component at B parallel to PB but induced by PA. And then we have the easy one. Delta BB is the displacement at B parallel to PB induced by PB. I make a mistake here. So the first thing is that we want to assume that PA is applied initially, and that after it is applied, then and only then PB comes on board. So first we have PA with nothing else here, and then once PA is fully in place, we hit it with PB. So the plot of the force versus delta curves is going to look like this. Delta AA is going to slowly rise until we hit PA. That makes perfect sense, I think. The load is applying slowly, and then we have PA applied. This one is a little trickier now. Now we're looking at delta AB. It's the displacement component at A due to the load at B. So what's happening? PA is going for a ride now. It's sliding along, and that's why I was fussy about the direction of the component. PA is sliding along in this direction due to the load PB. So that's why it's a rectangle here. And then while PA is being applied, remember PA was being applied first, PB is doing no work because it's not even there. And then PB is being applied, and it's only riding through delta BB here. Okay, so the work done is stored as strain energy, and it's a triangle, a rectangle, and a triangle. So here's my triangle, 1/2 the base times the height. There's my rectangle, PA times delta AB, and there's my triangle, 1/2 the base times the height. So once again, the 1/2 terms are only used for these linearly increasing loads when it's sloping up or ramping up from 0 to the final value. But the rectangles are there when it's going for a ride. Okay? Then next we're going to assume that PB is there first. And once PB is fully applied, then PA pops up. So how does that work? Well, we're going to start with PA to keep this in line. So while PB is loading up, there's nothing happening. So during that delta A due to B, there's no work done by PA. Let me repeat that. During the PB loading, the displacement at A is non-zero, but there's no work done here, okay, because PA is not there. And then PA shows up, and it's in line with delta AA here. So just be careful with these subscripts. Then we have what's going on from PB. Well, PB is there, PA isn't. So we have delta BB and PB, that's the triangle right here. That shows up nice and neat, no problem there. And then what happens? PA kicks in, and now we're looking at the work done by PB on B due to the force at A. So the double subscript is super helpful here, and that's the rectangle. So here we have a triangle, and a rectangle, triangle, triangle, and a rectangle. And then I guess the next part is, again, kind of like I said, some kind of obviousness here. The order of this application of loads cannot possibly matter. So U in the first scenario has to equal U in the second scenario. And the 1/2s cancel here. This 1/2 cancels, and we're left with just the two rectangles. So the two rectangles are equal to each other. PA times delta AB is equal to PB times delta BA. And this is a version of Maxwell's reciprocal theorem. So this is an amazing, amazing moment in the course. Maxwell is a genius. He's the same Maxwell who figured